How does CRF design relate to database design? Well, the purpose of the CRF is to collect all the required data in a manner that supports analysis. The purpose of a database is to store that data accurately, reliably, and in a way that allows it to be retrieved or used for analysis. The CRF data we enter into the database will be stored as records and fields. We can also think of these individual bits of data as variables. This sample comma-separated value, or CSV file, defines the fields. In the first row, we have last name, first name, and email. Below these, we see the actual data entered for those fields. Joseph Bogus at bogusj@wascourt.net. The other image is taken from the REDCap database that we'll be using. When we build the REDCap database, we define the field type, give each field a label and a variable name, and we also add restrictions to the format and type of data the field will allow. These are referred to as properties or attributes of the field. We define the properties or attributes of a field based on the type of data they contain and how we want to use that data. We can also specify allowable ranges for the values or require that a response is entered. Here's an example of the way we define fields in the REDCap system using the CSV format. The most common properties or attributes of fields include defining whether the field accepts numeric, text, or date data. The way we want to use the data will dictate what properties or attributes we define for it. So let's take a look at the difference between numeric and text data. If we want to measure or calculate a blood pressure value, we need to collect it as a numeric value. Defining the field as one that only accepts numeric values allows us to ensure that the site can't enter text stating that the blood pressure is high, low, or normal. Why do we care? Because we can't quantify the text phrase normal or compare one site's concept of normal with another site's concept of normal. Numeric values also lend themselves well to what we call range checks. In the example here, we've stated that all wait responses should be recorded in integers between 80 and 200. We did this in part to reduce the chance that the site will incorrectly enter a patient value of 120 pounds as 220 pounds. If they did so, they'd receive an error message warning them to review that entry. We can also run a protocol deviation check now, looking for any patients who weigh less than 80 pounds or more than 200 pounds, something we couldn't do if that was entered as text. Why not make all fields numeric? Well, sometimes collecting the data accurately requires the entry of text or date formats. Adverse events are a great example of the place we collect text. It would be impossible to create a list of every possible adverse event and load it into the database as a numeric field choice. Instead, we allow the site to enter descriptive text and then compare that to the list of similar terms. So we can assign all those similar terms a numeric code and then quantify them. Think of it as the various ways you could describe a headache: head pain, head hurts, head aches. These can all be converted to a code that indicates headache, as opposed to trying to collect all of that text and analyze it. Dates can be entered as numeric data, but we can also define them as dates with a specific date, month, and year format. That actually increases the consistency with which they're entered. Earlier, we noted that we can collect dates in several different formats, but that using a consistent format reduces entry errors. Well, we can also reduce entry errors by allowing only valid dates to be entered. For example, we can restrict the entry in the month field to values between 1 and 12, so that you don't get a month of 13 or 15. And we can block the entry of a year that is less than 1920 or more than 2020. These are all great ways to reduce the number of errors that are entered into the data. Earlier, we talked about assigning numeric values or codes to text fields such as AEs or CONMEDs. But we can also assign simple codes or values to fields such as yes, no, where 0 equals no and 1 equals yes, or something like 1 equals mild and 5 equals severe. A drop-down menu of acceptable coded responses is called a code list. Assigning a code list to the possible responses reduces the chance that we will get an unusable response, and it allows us to easily quantify the number of responses coded as 0 equals yes. Here is an example from the REDCap database. Whenever possible, you want to avoid asking site staff, or humans in general, to manually calculate values. Let's go back to our example of collecting date of birth and age. In that example, we noted that asking the site to enter both the date of birth and the age is likely to result in errors. A better approach is to have the site enter the date of birth and then allow the computer to calculate or derive the age. Here are two examples where we will be calculating or deriving values or entering them in REDCap. How do we document the connection between the fields we've got on the case report form and the fields we'll be using in the database? Typically, this is done by creating an annotated case report form. A blank copy of a paper case report form is annotated by noting the variable names next to the CRF field it'll be associated with. This example is provided by the CDISC standards group. The bolded text in parentheses are the variable names that will be used when programming the database. For example, in question 1, were there any medications taken, that'll be recorded as variable CYMN. Some organizations record additional information on their annotated CRF, such as whether they are using hard or soft ranges, or whether they've said a field is response required. When naming database fields or variables, it's helpful to use consistent and self-evident naming conventions. For example, you might want to start all fields on the vital signs form with the prefix VS, or you could choose to use the root DAT for all date fields, such as AE start DAT or AE stop DAT. Using consistent and self-evident variable names will reduce the possibility your staff will confuse the variables, and it'll speed up the study management tasks, such as writing edit checks or other programs. The annotated CRF will be used to design the database and to develop the data management and analysis programs that will support the study. It's important that the annotated CRF be up-to-date and easily accessible. Any changes to the CRF or database should result in an update to the annotated CRF, and a copy of the annotated CRF should be stored in the data management files and in the trial master file upon study completion. We have touched on various ways in which consistency reduces error rates and reduces the time required for many data management tasks. We can extend that concept of consistency into the area of standardization. We can use standard procedures to complete tasks. These are known as standard operating procedures or SOPs. We can also create standardized versions of frequently used case report forms and define standards for naming and creating database fields. Having standard CRF forms and fields allows us to create standardized reports and programs for managing and analyzing our data. These types of standards developed within an organization or company are referred to as company or department level standards. But we also have industry level standards, standards that aren't enforced by governmental regulations or laws, but that are considered best practice within the industry. And finally, we have regulatory standards that are created and enforced by regulatory authorities such as the FDA. We can establish standards within a particular department or therapeutic area, or we can extend standards throughout an entire company. Some multinational companies have regional standards that reflect the technological, regulatory, and cultural attributes of that particular region. These standards can also have multiple levels. For example, we might have project-specific entry plans, which tell us how to enter the data for a specific project. Or we might have department-wide work instructions that tell us how to create the project-specific entry instructions. And another step above that would be company-wide Standard Operating Procedures, or SOPs, which would state that every project must have entry instructions. Each chapter in your Proshka textbook will include a brief paragraph describing the SOPs impacted by or needed for a particular process. Industry standards are informal expectations for good data handling. Sponsors and CROs will expect you to operate using these best practices. The Society for Clinical Data Management, or SCDM, has published a list of good clinical practice data management documents, or GCPDM. As I noted in Module 1, Proshka has incorporated the SCDM documents into her text, but if you ever need direct access to the documents, you can purchase copies or join the SCDM and gain access to free versions of the copies. Also, remember, while you're not required to comply with FDA and ICH guidance documents like you are with regulations, the industry standard is to follow those guidance documents, so you'll need to be doing that. In Module 1, we talked about the FDA regulations for 21 Part 11 as well as for electronic data. And we do need to comply with all of those. But in this case, I want to talk specifically about regulations involving standards or standardization. Right now, there are a few regulatory standards for the naming or structure of clinical data. In the past, each sponsor utilized their own proprietary standards and simply submitted documented datasets to regulatory reviewers. However, in February of 2014, the FDA released 3 draft guidance documents, which propose that starting in 2017, all electronic submissions to the FDA will need to comply with CDISC standards. So let's talk a little bit about CDISC. What is CDISC? CDISC stands for the Clinical Data Interchange Standards Consortium. Over the past decade, there's been a push to develop industry-wide standards for collecting, storing, and reporting clinical data. This effort is being driven by the Clinical Data Interchange Standards Consortium. CDISC is comprised of volunteers within the pharmaceutical industry and various regulatory agencies. The primary CDISC initiatives are C-, the Clinical Data Acquisition Standards and Harmonization Group. C- focuses on data collection, how we name and define the fields we use to collect clinical trial data. The C- Working Group has defined standards for many common CRS, including the AEs and vital signs. Throughout this course, we'll refer to the C- standards. The STDM, or Study Data Tabulation Model, focuses on standards for storing and displaying the study data tables used during regulatory review. The ADAM, or Analysis Data Model, focuses on standards for the organization, structure, and format of analysis datasets and related metadata. This includes standard dataset structures, variables, and naming conventions. We're not going to discuss the CDISC standards in depth in this course, but you do need to be familiar with the major CDISC initiatives, and you need to be familiar with the fact that the FDA is planning to require submissions in CDISC format. If you want to know more about CDISC, I'm going to have you explore their website, and that's going to be part of your assignment. Your assignment for Part 2 of this module is to read the pages in your textbook on database design considerations, pages 23 to 36. I also want you to explore the CDISC website, and we are going to review a mock protocol synopsis and mock analysis plan and create a little visit and assessment matrix for our mock trial.